So, hello back again. A short, late in the evening stream because life changes. And with life changes come opportunities, and with opportunities comes bag number 6 of OSSC building. But before we get into bag number 6, here's one thing that I skipped in the beginning, which is these two ICs here have one pad that hasn't been soldered yet. And that actually is on this side of the board. These two pads, they're ground pads, and they actually have not only a thermal function, but actually for these two chips an electrical function, so we need to solder them in order to get things to work. And again, there's a couple of ways of doing this, and I just want to show one, which isn't necessarily the best one, but it does get the job done. So we're going to switch to the scope. Going to have a look at this. And we're going to see this here. And basically, yeah, we can see the bottom of the chip through these holes here, and I can actually bugger the chip like this, and that goes for both of these. And basically what we have to do is make a contact between the chip and some, or at least best the central via here through the board. And of course, if you're using thermal paste, this would have been one of the first things you do. You stick some thermal paste between the chip and the other side of the board and heat this up. Get that to solder and bind, and you'd be fine. But if you can't do that because you're out of solder paste, you only have the magic swearing stick wand. There's other ways to do that. It doesn't look as pretty, but it does work. So the first thing we're going to do is we're just going to pour some flux in here. Doesn't have to be too much flux. It also doesn't have to be very accurate. This isn't going to look nice and pretty. It's supposed to work. So, and what we're actually going to do is we're going to put some solder here. So once we touch this with the hot solder iron, the flux is going to just go and suck everywhere. And what's going to happen is we're going to create a dab once things heat up enough. This can take a while depending on the thermal capacity of the solder iron and the thermal capacity of the board and a lot of other factors, where this is just gonna take a while to heat up because we're soldering to the ground plane, and that's not the simplest thing in the world. So after a while, you're going to notice that it's not going to take too long for this to heat up because the thermal capacity of the board is exhausted, and that means it's going to heat up, and it's also going to heat up the chip underneath, and it's going to leave you with a blob like this. Now that doesn't necessarily mean that the chip is soldered on, but just for good measure, we're going to do the same thing over here. And put some solder in here and feed some solder in here as well, and it's gonna take a bit to heat up. And once it does, and you don't mess up like I just did, you're going to be left with a solder blob like this. And you can see the thermal capacity here of my soldering iron is barely high enough to actually grab through this and heat up all of this and get it liquid. But eventually everything's gonna go and heat up enough that we can get stuff stuck on there. And I'm just going to put a little bit more solder on here to prove a point later on, because we're going to need a little bit more on both sides here. There we go. So we need to get more heat onto the chip especially, so we're going to use hot air to do this. And that means that sooner or later, once this heats up, we're going to need a little bit of time for this to happen, and get a little bit of heat on there and thermal energy there. And we're going to move around a little bit. We don't want to thermally shock the entire board. And I usually do this during the heat up process. And you're going to see that excess heat that's going over the chip might actually liquefy the solder over here. So we're going to try and take this from a top position. And as you can see, the solder is going to go and liquefy, and there's going to be a point where some of the excess, there we go, some of the excess flux is going to boil off inside, and it's going to go whoomp and just flow right under the chip and make a solid connection right there. Now, the board is going to be really shitting hot at that point, so be careful where you touch it. And it might happen that you have some blobs like this, and this is quite possible. Usually this chip is the larger chip, so it's going to take more power and thus more thermal energy to heat up to that point. And you can see the flux blowing up and bubbling up. And of course there's going to be some flux underneath the solder blob we made, and you can see it dripping and shooting out there. So take care with your fingers at that point. And the solder is going to melt once we reach a temperature that's high enough. And there's going to be a point where you can see it cooled off rather rapidly again. And I can touch it with the tweezers, and it's just like just on the brink of being hot enough. So we're going to heat it up just a touch more and give it a touch more power here. And there we go, and it's going to melt, and that's going to heat up the flux in between, and that's going to produce quite a bit of smoke. And there's going to be a moment where this is just, and you can see here it's liquid now, you know, and I can stick my thing through here, actually, my tweezers onto the chip. So I've done that. And there's going to be a point where this is just going to join together, and it's going to be done. So it doesn't necessarily have to actually build this form of connection or this vacuum-ish thingy. It can just stay like that, and that may also just be a good connection. Again, on this board, I'm just going to show you again what's going to happen if you heat this up again. There's going to be the change in the solder that's going to happen once it liquefies, and I'm just going to try to pass off that moment. So we've got solid, 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 and there's going to be the change, and you just saw it going there where it goes into a liquid state. And you can see that by just pushing on it, it just pushed into the board a bit, so it's it flattened out a bit, and that's basically where it creates the bond with the chip. Again, you can use solder paste to do this. Now you can use a magic method of cooling the board, waving it around a bit. And yeah, that's basically one way of creating these connections without solder paste. Of course, it does take a bit of time, and it takes a bit of know-how and feelings to not burn the chips entirely. But yeah, basically that's how it works, and usually you can tell that you didn't too much damage by not having a gaping hole in here, which is always a good sign. And yeah, that's that part. So after we've done that, we let the board cool off a bit. That's why I just did this right here, to relieve the stress. And we're going to have a look at our desktop image here, which is going to tell me that we're at bag number 6, which is miscellaneous parts, which is 2 fuses, 2 quartzes, clamping diodes, which are a rather tricky thing to do, infrared diode, and a screen. So we move on to the part of getting that on there. Luckily, it's 1 each except for the clamping diodes, and the clamping diodes are always a tiny bit tricky because they have a direction, because they're diodes, and these especially are a tricky thing to do. But we'll just start with the fuses, and that means we're gonna grab one of these fuses here, which is F1, which is a 1.5 amp fuse, and this fuse goes directly on the main power rail. So now this is the part where we start actually, and I'm going to switch back to the scope here, where we're actually gonna finalize the connection between the main power and all of the rest of the circuit. So we're going to have a look at this. Here we go. And we're going to put that here as well. So now we actually have our 5 volts coming in here, going through there, being filtered here, and going all the way here, where there's going to be the on-off switch, which is going to short this once you plug it in, which then goes to all of the power rails, etc., etc. So that's our first fuse. The second fuse is a fuse that protects our HDMI output, and this is a resettable fuse. And it's tiny. So this is F2, our second fuse. And I'm just gonna unpack all of this here and put this back. And our second fuse is next to the HDMI connector, which is here. And it works the same way as all of the other components. Basically, we tap one piece here, and somehow something doesn't like me right now. So we're gonna try and unplug this for a second, because somehow the camera's stuck in a feedback loop, which is nice. So we're gonna go turn this off, reset this, and just turn this back on, and hopefully things are going to go back to normal. Let's see. This part works. And we're going to go here. And yep, that looks better. And we're going to have this here, go here, and let's hope that doesn't happen again. Now I throw over all the stuff, but okay. So we're gonna have this tiny fuse here, and we're gonna solder it on one side. And then you're just going to take the entire thing and solder it on the other side. And this basically is a 5-volt that goes onto the HDMI connector that comes out here. So that's that. Now this is the point where some of the parts get bigger and some of the part gets smaller again. First of all, we're gonna have this quartz. It's a 24.576 megahertz quartz, and I'm gonna show this to you in a second. See, and here we go. This is what this looks like, and in comparison it's huge to all the other parts we've had before. And this actually goes in here, and I'm going to do this off camera. I'm just going to stick this through here because these legs are very long, and I'm gonna put them here in a way that this basically lies on the board like this. And I'm going to turn the board around and just put this on a flat surface, and I can solder these two leads onto this, and that's exactly what I'm going to do. So that's one of a couple of through-hole components that go on here, and that's number one. And we're gonna go and grab number two, and there we go. Now we're gonna snap off these two leads here. And I'm going to just use my fingers to secure them so I don't shoot them into my eye. I'm going to double check that this isn't shorted, and that's the first quartz. Now next comes the second quartz, which is a 3.3 volt 27 megahertz standard oscillator. This is a big package and comes in a very big box, so I'm gonna show you in a second. So it's gonna look like this, yeah, and it goes on the board onto this cutout. And this is where in the last episode we had some solder in here, and I said it's not an issue, it's actually going to help us in the future, and that's exactly what it's going to do. Now the package goes on with the pointy edge towards the pointy edge, and I can just take it, and this is a little bit hard to see. What I'm going to do is I'm going to take it like this, so I actually have the quartz with my thumb in 3 of the 4 holes in here, and I'm gonna push ever so slightly and liquefy this hole, and it's just going to snap into place, and it's going to cool, and everything's going to be fine except for the ferrite bead that I knocked off by doing so. So I'm going to go and look back where I had that ferrite bead, so which probably means that the solder joint wasn't the best of all solder joints, and I'm just going to grab it and get it off there. There we go. And just have it soldered back on. And I'm going to solder it back on this side as well. There you go. And maybe later some heat's gonna fix that as well. So now I have these leads here, and I'm just gonna solder, give them a little shiny solder connection here. 1, 2, 3, and 4. And that basically is going to look like this. And yeah, that's that quartz. And that leaves this package with only 4 components, 2 of which are the clamping diodes. And now these can be a little bit tricky. So I am going to take 2 of these, and I'm going to show you in a second why this is so tricky. I'm just going to put this back, and the reason they're so tricky is they go here, D6 and D7, and they look like this. And you're going to see they have tiny connections on the bottom that don't protrude to the side as much, so they're a bit tricky to get soldered on. And again, there's a couple ways of doing this. One way, and this is just an example, I'm going to put them on the side for a second, is again the liberal use of flux. Then the pre-tinning of the connections, and by using flux you can apply a little bit of solder here, and it's gonna only go where it needs to go. A little bit of this is just gonna be enough. And now in this case I'm gonna use hot air again. I'm gonna wait for the hot air station to heat up, and I'm gonna put this here and roundabout arrange it where it needs to go. And I'm gonna come from rather far away and slowly heat up the thing. And by doing so, I'm gonna start heating up the pads beneath it, and it's gonna start to wiggle a little bit and drop into place, and then I can remove the heat and it's gonna cool off. And I'm gonna do the same thing for the one on the other side. Now, it's not very easy to see when this actually happens, and when actually the pads go from a solid to a liquid state. But that's not that bad actually, and of course if you're unsure you can have a look at it like this, and you can see that actually there is a small protrusion. So once you've got this on and this aligns on both sides, you can always add some more flux to this, and you can actually use an iron add a little bit of solder to it, and you can actually just go and touch these up a bit, and if you don't overdo it, it's gonna turn out just fine like this. So we're going to do the same thing on the other side. And there we go. There we go. And this is a lot harder on the camera than on a different microscope, but eventually you're gonna see that they're just gonna drop into place. Maybe put a little bit more here. There you go, that one and that one. Again, this may be hard to see, and you're going to have a close look at it, and with the flux you can see that there actually are connections here and on the other side as well. Yeah, so that's always a little bit of a tricky part, especially if you're not experienced, because this is way smaller than soldering all of the other parts, but from now it gets only bigger. So the next thing we're going to need is this infrared diode, diode sensor, well, which goes onto the top part of the board right here. Put this in focus again, and we can just drop some solder here and then arrange this diode sensor here and not chip it off the board. You go here now, and you're going to be nice and behave. And we're going to put you on there. And we're going to have you sorted here. So again, this can be a little bit tricky because there's 3 joints on the bottom of this that need to be soldered. And that can be a tiny bit tricky to do if you don't know where it needs to go. But again, it's not that bad once you know that you actually have to go there. It's just a matter of grabbing this under here, getting the heat where it needs to go, and getting the solder where it needs to go. And of course, again, you can use a little bit of flux to help this process along if you think you need it. And there we go. Again, it's not the nicest of soldering on here, but this is rather unusual for me to do. And here we have one of these solder flakes again. Get rid of these as soon as you can, because they have a tendency to stick somewhere on these pins, and that's not gonna be fun at all at any point in time. So having shorts because of these little flakes is something extremely annoying. So next step is, and the last step in this package, is our display. So we're gonna have a look at our display here. Display looks like this. This is a close-up of the display. Not much to see. It has a couple of pins down here, and it has on the other side, it has 2 pins that go on top of the board. So these go on the bottom. The right one goes on top of the board. And this basically locks the display into place. And there's also these 2 plastic notches there that use this to interconnect with the board. And we can align this with the board as so, because this is where it goes, and use a little bit of force to put this exactly where it needs to go. And on one side, it's gonna now look like this. And you're gonna have to riffle a bit with it to get it aligned in a position where it's 90 degrees angle, or not care so much about it, because there's, you know, always a little bit of force you can use, but try to get it nice and easy. And then we're just gonna go and tap these, tap this one, tap this one, tap this one. And you might get a solder joint here going. It can happen. You know, if you have something like this happen, don't worry about it too much. It can work just fine. And we have a final one. And we can basically get things soldered on here. So this is one side of thing, and then we have the other side, which again, now we can still push this a little bit into alignment, but the alignment roundabout fits. And one of the issues we can have here is that actually these are pretty hard to get soldered on this side, because as you can see, it doesn't want to flow on top of this, and it has to, and that's important. For some reason, you're going to want to have this to actually interconnect with each other. And that can take a while to get done until it fully goes to connect to each other. But it may keep some spots there left. But if these don't tightly and cleanly connect to the LCD, things are gonna look and work very strangely. Yeah, so these can be huge solder blobs, and you're just gonna have to work with it on that point until you get some weird looking blob like this. But again, you know, there's worse, and this is usually just hidden by the casing anyway, so it's not that bad. Try not to get too much heat onto the LCD display and keep the cover on. And basically, that's bag number 6. That leaves 2 bags open for today. Bag number 7, which is all of the connectors, and bag number 8. Bag number 8 is just a set of mechanical parts that go into the casing, which I'm definitely not going to do today, but I am going to put on all of the connectors, which puts us a lot closer to a first working and inspectable piece. Depending on how you like to solder your stuff, you might want to go from lower parts to higher parts, but I've already put on the display, which is one of the highest mounting things here, so from now things are not going to line up as nicely, and there's going to be a lot of refocusing. And this is the connector that takes a VGA signal, and we're just gonna grab the iron and solder all of these into nice little happy little solder joints. In case of this solder, we want to have them nice and shiny, because that means they're a good solder joint, and a good solder joint that is nice and shiny is something that we want. Yeah, and we're just gonna solder through all of these as well. Not as easy this time. Come on. Be a nice little solder joint. Stick. And you stick 2. And you stick 2. And here you go. And here we go again. And there we go. That gives us those connectors, and we can of course also solder on here if we want to make this a more stable physical connection. And I'm just gonna have to refocus in a second. Refocus here. Now we can just take all 3 of these and make them connect with the ground plane on the bottom to give us a nice solid connection, because this is one of the parts where cables are going to be yanked in and out of, and we don't want this to rip off that easily. So putting a little bit of metal here is definitely going to help us out. So There we go. That solids up that connector, and next is going to be, where are we? The JTAG connector. And we're going to take this. This is basically just a standard connector that goes here like this and gets soldered on the other side. There you go. And I'm just going to flip this here and show you what I'm going to do in a second. So I am going to solder one joint, then I'm going to pick up the entire thing, push the connector onto the board by hand, and resolder that joint, which makes it flat on the other side. This allows me to then take one of the joints on the other side of the connector, solder it on, and keep it aligned properly, which makes it look nice and nice and clean by not sticking on there in a weird angle. And yeah, well, that one could have been better. And cut off some solder here. And basically this is where this connector goes. And once we see this, yeah, there we go. And we've got that one settled as well. So Louis Rossmann, by the way, you should follow him and watch his videos as well. Hates JTAG connectors, and there may be good or bad reasons for it. In our case, we are really gonna need this for the initial programming of the device. Next is going to be two push buttons, which look like this, and they have a tiny button on top, and they have these clamps which go into the board and go through the board, and it takes a little bit of force and convincing to push these on there, but these two just click into place, and they have little plastic bobs on the bottom which makes sure you don't misalign them, and they actually have holes on the board, and you can see here where these go into, which make sure that you align them correctly and don't short them in any way. Now again, I'm just going to grab this through hole and get this soldered on here. Make a good solid connection for 1, 2, 3, and 4 button pins on this side. And then, after a lot of refocusing again, I'm gonna do the same thing here for these pins as well. And the final one, we're just gonna solder on here. And there we go. That's that. And another mechanical bag from this set out there. Now we're gonna have a audio switch, which can be used to switch the audio input of one of the audio channels, and this is gonna go right here. This is going to be switch number 4, and it's again, you stick it in there. Idly, you grab your soldering iron, put some solder on it, lift up the entire thing, turn around, apply pressure to the button, solder one pin, and it aligns and sticks perfectly. You can then turn it around, and from the opposite side of the button, start soldering these, and that's going to make a good physical connection and align the button with the chip. And I refrained from swearing because the button does get rather hot when you do this. It's gonna burn your finger, and that's quite a painful thing to happen. There we go. So we've aligned that one as well, and we're down another bag. So next is gonna be what we have here, our power supply connector. And this as well, this goes here next to the display and has these 3 buttons, and I'm gonna stick it in there. Again, turn it around and solder one of them. While checking for the alignment of the connector, and we can heat up the one's joint we've done and move this around until it drops into place and gives us a nice and fancy there you go, connection here. After that, we can go and solder on the other 3 connectors. Sometimes takes a bit. There we go. Now we can just as well do this one here. I'm just going to feed some solder in there, and there we go. And we've got that one on there as well. So that's our power connector. And now we're down to 1, 2, 3, 4, 5, 6 more connectors, which are a little bit of more work, but we're getting there. We're getting there. So now, right next to the 2 push buttons is the first audio connector, and again it's the same game. Solder one joint to fix it in place. And once it's in place, solder the other pins of the connector to create a nice and aligned position of the audio connector right here. And we'll do just the same thing for the second connector, which is easier to do off cam right now. So give me just a second before I can show you this again. So yeah, we're just soldering in the audio connectors here, and that's gonna put this on the board in the right orientation and on the right spot. One more down. Now we're gonna take one that takes a little bit of force. That's the RCA phono connectors. We've got this blue, green, and red, which goes onto this weird looking set of vias here, and can be a bit of a hassle to plug into and might take a little bit of strength to get there. But once it clicks into place, you can align it correctly onto the board. It has a couple of notches, again, where this can show you the correct alignment. And once it flips in, you can just start soldering the connections. And you can just fill this with solder to get a nice solid connection on all of these grips here. And sometimes it doesn't want to go like that, and there you go. And sometimes we don't get enough heat on there directly, so we're gonna use a little bit of trickery to heat up the entire thing. But the moment's gonna come where we have enough power in there to stick this on there and keep it there. Again, this should be strong solder joints because there might be actual force here, and also with using so much solder, there is a rather high chance that you're just gonna push and have your finger right on the entire thing, and that's gonna be painful if you're not used to it yet. Yeah. There we go again. And of course, putting so much thermal energy into a board like this can cause it to keep its nice warm temperature, so be careful when handling it. But also means if you don't stop for too long when doing these solder joints, you can use the excess heat that's on the different planes to just make this go a tad bit easier. To get all of this solder flowing here and thereby helping you out with this. So there we go. So that's the RCA phono jack, and that leaves us with just 3 connectors, and one of them is the SCART connector. Now these 90-degree angle SCART connectors I bought from China because they're rather hard to get here, and they have these tweensy little connectors here which always bend in the bag and whatsoever, and they go in here, and that's a huge mess to align and get just right. But once you get that in there, it's just a simple matter of soldering that onto the board, and you might have to squeeze and squinch and do some stuff to get all of these aligned. But again, eventually and with experience, it's gonna just click into place and hopefully have, let's see, no, not quite. I missed one of them. this again. And hopefully this time all of them will go where they need to go. Nope, not again. So third time's the charm. There we go. So that's going to click into place and look like this from the top, and beautifully look aligned like this from the bottom. And we're going to follow the same procedure of just soldering all of this into its correct positions. There we go. 1, 2, 3, 4, 5, 6, 7. There's this solder blob that I don't like, so I'm going to put that in there. I'm just going to go to this one. I have to re-angle the iron for this to not hit those capacitors on that side. And go right there. And you can see that this is a ground plane because it doesn't want to behave, because it needs more time and more thermal energy to actually route. I'm going to put this here. I'm going to redo this one. That one didn't look too good. That one is better now. And again. And again. And just a couple more here. And oops, here. I'm just going to reflow this onto here. Another one. And just 2 more. There we go. And that one doesn't look its best. I'll just put some more on that. And there we go. And you can see they're nice and shiny for the most part because you can actually see my reflection in it. Got this one, like that, nice. And look at this one again. But yeah, that's basically just how this is going to work. And we have a soldered on SCART connector. We have short visual inspection of this work, not under the microscope, and I've had worse, to be honest. So another one down. Now there's just 3 more parts on this that actually come from this bag. One is the SD card slot, which you might want to add. The only thing you need it for is to upgrade the firmware if you do not have a JTAG connector on it. And you do need the JTAG connector anyways. So basically, yeah, a JTAG is mandatory, at least for initialization, while The SD card slot is a convenience thing. I always add one because I just bought a 50 or 100 of them a way back, and it just goes, let's see, let me get this right here on. Yeah, it just goes onto this pin here, and then you just align this on top. Once you're there, and that's where that's going to go, and that's where that's going to go. So we're going to move this down just a pinch like this, and solder on the connector on this side, and now we can solder on these front loading connectors here. Now if you have, depending on the SD card you have and the connector you have, you're going to have to be a little bit careful here when making these connections, because if you have solder points that stand out because you pulled off the iron to the top instead to the side or to the bottom, this can cause scratching on the SD card, and that's never nice. And of course there's the solder bridge we have there, which we're gonna remove with a tiny bit of flux that we're gonna put on here. And if this does focus, it doesn't really want to do this here, but yeah, the white balance just gets shot off by the SD card plate, metal protector plate. So we've got that here, and just gonna tag this spot here because this is the HDMI connector, which we've got one right here, which is almost the last part of this entire soldering project. And this can be a tiny bit tricky to solder on. It goes here, and it has these small pins here, and it needs to align quite straight, and that can be a tiny bit of a pain. So what I try to do is get some flux on there again. Here now it's a little bit more care should be taken with the flux, because you don't want the flux inside the connector because it's a pain to get back out. So be careful with the liberal use of flux. Then load up the iron with some solder and try to get this into a position and just tap it slightly with some solder. Again, if you have connections like this and you get bridges, it's not as bad as you think. You can get rid of that excess solder rather easily, and the flux is gonna help you with it. But before you put too much work into this right here, this can be a bit of a pain, we're gonna solder these 4 pins on the other side. And again, these are rather important to get a solid connection. Let's get the right side here. To to get this a solid, give this a solid connection, because this is again where the force of any cable pulling is gonna end up, and you don't want these to break off because they generally rip off some pads, and that's just not nice because it means a lot of work. Hence, add a generous amount of solder. Make sure it goes through the hole and settles right there. So now once we've got that done so far, we're gonna have another look at this, and you can see solder joints here aren't quite through. Here they're through, so we're going to go over that in a second, but we're going to look at those solder bridges here again. And again, we're going to use flux on this to just try to convince it to not be a pain in the ass. But if that doesn't work, we're gonna go and grab some solder wick. Let's see, where did I put the solder wick? Oh, I seem to only have this solder wick, so I'm gonna maybe have to make do with this piece and just stick that on there for a bit, and that's just gonna take a bit to heat up, and with a little bit of luck it's gonna pull off the excess solder. And let's get this done here as well. Now this is pretty thick solder wick, so this might take a moment, but yeah, okay. So now we can go and have a look at this again. And maybe get this into a little bit of better state. But yes, this can be a little bit finicky because this connector basically buggers the hell out of everyone who tries to solder it on. Again, using some flux to get this connected, and eventually you're gonna get into a situation where this is gonna just clear up. Always helps to have a clean soldering tip. Take care of your tip or so, and because that's gonna help the solder climb onto the pin. If it doesn't want to work at all, again, we're gonna grab some of the solder wick. This time I'm going to grab a tiny piece to help with the thermal coupling, and we can just go there. And sorry for moving this out of frame. And just move this here. Have this out here. Now we're eventually going to get into a state where this is going to line up correctly. And we can have all of the nice connections that we want. Sometimes you get tiny little solder blobs underneath, or next to it, and they're not going to be as nice as you want them, which usually means you're going to have to add more solder to them. So basically you reconnect the joints and you bridge this off again up to a point where you're not having a, come on, behave. Up to a point where you're not having any issues anymore with all of this. Maybe put some even more flux on here. So much eating my own words. Do not use too much flux on connectors, but also don't use too little. Okay, I'm gonna try again with the solder wick. This one's especially resilient this time. And sometimes, in some very rare cases, you might want to get a little bit more physical and just attach this, which basically means you're going to have to get in there in a manner where it's a tiny bit of scraping that needs to be done, which always has the risk of touching a pad or ripping something, so you don't want to go into too much depth here, and you can just touch these tiny pads here again, and then you're gonna get this done. Now, once you have this reasonably done, you can look at it under an angle, and there's gonna be a way for you to tell if there's any solder under the connector, which can happen on some occasions, and you can have a look at it, and we're later gonna double check by measuring this. But for now, we're going to be fine with this, and we're going to have the final piece of the puzzle. That's the power switch, which comes last. And that actually concludes bag number 7. So we have a power switch to solder on. I'm just going to do this off camera real short because this is again one of these grab, touch the metal switch on some metal parts, heat one leg, heat one joint, properly align on the board, and then complete the soldering process. And it's gonna go right there, and we can actually solder on the rest of this connector. Again, make sure this is a switch that's going to be pulled, pushed, used quite often. use copious amounts of solder, make sure it goes through to the other side, and make sure it's a good solid connection. You can usually also tell if it takes a while for the connection to reliquefy after applying heat. That means a lot of thermal power is transferred, which means that the connection isn't half bad. And this, dear gentlemen, ladies, gentle beings, ouch, I just burned myself, actually means we have all of the parts for the OSSC assembled on the board. And I can change it here, and maybe put this on the camera here. I don't think it's going to focus that well with the ring light, but there we go. And yeah, the next steps are gonna be the following. I'm just gonna take a little clean off, and then I'm gonna get a multimeter, and we're gonna do some of the very first checks on the entire board. See if the power rails are shorted, or hopefully not. And in between, I'm probably going to take a little toilet break, but maybe even power it on if all the checks turns out. Let's see what happens. So first thing, let's make sure we have a multimeter here, and I'm going to make it beep, and I'm going to see. Well, you should be able to at least a little bit hear what's going on. And yeah, this is basically going to be what goes where. Well, let's see where we want to go. First of all, we're going to go and want to check if this works like this. So this is the button in the on state. And let's see what happens. So first, the bad news, we have a short to ground. And that's not going to be too much fun to look at. But the usual suspect actually is this connector here. So we're going to have a look at these two connectors here and whether they're short to ground or not. And they are not. But these two are. And or are they? So these two are shorted to ground. And if I remember correctly, they shouldn't be. There are connectors that are supposed to short together. This one doesn't. This one doesn't. This one doesn't. This one doesn't. So basically, it's these two. So we're going to have a closer look at this one. And we can see that there is probably a tiny short. So these are hard to see again, and means we're gonna put some flux on this and gonna try and clean this off. I'm gonna go back to scope here. Let's have a look at this. Well, that for sure. Now I made sure it's a short. Where did all of that come from? We're gonna go there and suck off some of that solder. Let's see. Yep, there's still this tiny little connection, and again, sometimes it can be useful to actually use a tiny bit of force to get rid of something like this. Now let's see if we have some solder under here. Doesn't look too much like it. Have a check here. Let's see again if this is shorted. And now it is not. So this is looking better. Now go back and our short to ground is gone. So that's a first good sign. Now what I'm going to do is let's switch back to the workbench. Now I'm going to take a ground reference point, and I usually take the casing of the connector here to put my black probe, and from this point I'm going to touch a couple of points across the entire lower side of the board to check it for shorts. Of course, it should short out on specific points on the board, and it should beep, but it shouldn't short out on specific points, for example, on the output of power rails. Depending on how far I get with this, it's going to be a good sign, and I can try to turn the thing on, or maybe not so good sign. That's what we're going to check for. Now, first of all, of course, I'm going to check my 5-volt power connector, which should not short and should short. And of course, my switch shouldn't short because my switch is on the 5-volt power rail. It should short between it, so I know it's turned on, but it shouldn't short to ground on that. From this, and now I'm going to switch back to the scope mode, and sorry for scratching up this specific piece, but oh, I dinged again. If you have just followed, thanks for following. I can't see who you are right now, but it's much appreciated. Let's see if I can get the light better here. So what we're going to have here is my black probe to ground, my red probe here, and this should beep because this is ground, and so is this, but this one shouldn't be, and this is my 5 volts. These 5 volts now go through this fuse, which should conduct, which is cool, and through this, and go all the way through here to this switch. So this switch shouldn't beep because it shouldn't go to ground, and because it crosses over here and it's on, it means 5 volts go here, which means 5 volts go off of these traces, and they go to all of the power regulators. Now the power regulators should have, let's take this for an example, the top pin and the bottom pin, which is where the power comes in, they shouldn't connect to ground, so it shouldn't beep, but the central one should. Neither should the ones on the output side. So this one's good. This one's good. And the central one actually connects. Great. And now I'm going to do this for all of the other power regulators, which is just a short check if things so far go so good. And now I'm going to move over to the other side of the board. There's more of my power regulators here again. Nope. Nope. There we go. Nope. Yes. Nope. That's exactly what we want to see here. Nope. Now it should beep on the center pin and not on the outer pin. Great and great and great, and none of these should go short to ground. That's great. Now the reason I always check the center ones as well is simple, because it gives me audio feedback about A, this is a connection to ground, and B, the beeping works. Like literally, for some reason, these devices tend to just not beep when they should sometimes, and this gives you a feedback that like, okay, this is good, this verifies that the beeping works, so I'm pretty sure everything else so far is good, and these connections aren't shorted, and I'm fine so far. And the center one goes to ground, the others don't, and we have the final power regulator, which is here, which also, just to make sure, doesn't have shorts to ground anymore on here, except the center one, which is perfectly fine. So some other things to consider is there's always the matter of chip alignment, and one of the ways is to check actually which is the ground pin. So which pin connects to ground? That's this one. And then check in the data sheet if it should connect to ground. Another thing I usually do, and I'm going to switch to my desktop here, because now all of this is done as well as all of the above. So let's just get all of this X'd out to make sure we're done. And I can just turn this into full screen mode and go here. I'm gonna just flag the chips I have and check their first pins and their orientation. I've already done that at the beginning of the first video, but I am just going to recheck these by just pushing on them and seeing which pin is highlighted as pin 1, which is the high yellow one, and I have my indicators on these chips that usually indicate pin 1, which gives me an indicator, okay, this is supposed to be here. Pin 1 on this chip is supposed to be on the bottom left. For the big FPGA, it's supposed to be on the top right, which looking good. The IT6613 is on the bottom left, which lines up. And basically I'm checking this on the microscope while at the same time looking at the schematic for all of the basic ICs I have. Turn around. And basically that's what this whole thing does. And now after that's done, leave this for a second here. We're gonna go and have a look at some of the ICs and check this for different possibilities. So this is a visual inspection thingy where you go through everything, have a broad look at, is there any things you have that could possibly be shorted. For example, these two on the right look a tiny bit suspicious. And you can see already some crud has assembled on all of this. So this is later for a cleaning process. We're going to go through that as well. And we're going to look at the pins, look for any flakes that's on there. Look at anything that could be out of the ordinary here. Just going to go through all of this, go through all of that. And just generally check for obvious flaws. You're not always going to find everything, but you know, there's just some stuff that you might want to see. And maybe sometimes there's these things, you know, where you go like, okay, is this all soldered on correctly, or is this actually a solid connection or not? Is there any crud in here or not? And you just go through all of this stuff piece by piece and give it a thorough look at. Sometimes there's, for example, there's one of these notorious tiny little flakes that can really bugger you in the future. I'm just going to take that off the board. We're going to turn the board around, have a look at stuff around here. And see if we have anything that shouldn't be here. Okay, we still have some flux here that needs cleaning off. We still have some cleaning to do here, but there's no obvious shorts here. So there's no obvious shorts on this. There's no obvious shorts on this. There's no obvious shorts on this. This one, let's see. Yeah, this one's okay. That doesn't look that bad. That's okay. That's okay. So all of this looks okay-ish. So now it's time to clean off some of that residue flux, and then I'm gonna take a short break. And then we're going to continue with some measurements and maybe get to a point where we can try to turn this thing on. Now, putting alcohol on this to get it cleaned up. It's gonna take a couple of minutes. So I'm just gonna turn on this. I can just switch to this, and you can see that this is just me cleaning stuff with cotton pads and cleaning alcohol and getting in there and taking off that excess solder, and of course also checking for any other visual cues that might show some upcoming issues when we try to turn this on later on. Go. Just gonna grab the next one, get into this, and so yeah, this is a rather tedious and boring work, or well, necessary, but there you go. And you can have another look around the board. Let's see if we find anything that we shouldn't find. And we're gonna go back into this and go here. Go here. This looks where it belongs. This looks like solid connections. This goes here. This has some crud on it already, so we're gonna just pinch this off of here. And that means this is the piece where we gotta do some cleaning work here, because there's still some flux on this. So we're gonna grab some cleaning alcohol and get in there and get rid of some of this. And see here, and this is looking good. Looking good too. There's some stuff here. Yeah, there's some here. Now let's see if we have any obvious connections on here. Nope. Nothing obvious here. This looks good too. This looks okay too. There might be a tiny speck of something, but I think it's just a piece of crud. This pin's okay too. No obvious shorts here. No obvious shorts here. That one, that one, that were one of the fishy ones. And have to have a closer look at that one in a second. There's some crud on that one. And there might be a, where are you? There's a piece of crud on here, but that's probably not it. But if you have a look at this here, now where am I? Here, that looks like it might not belong there. And if you have a look at this, let's see. Might just be a tiny speck of stuff that's stuck in there. But yeah, it looks better. Is this a connection that's open? That's okay, but is that down there okay? Or is that one of those tiny specks of something? Let's see. That looks better. That looks okay-ish. Yeah, this needs some cleaning up. And there's a solder bridge right there. And this is where a microscope becomes really helpful, as you can imagine. So we're just gonna grab these and just make sure that these are not connected. Touching these up. Need to clean that up in a second. Check this. So we're gonna go grab alcohol. Check on these. Check on this. Let's see. So this one here might not be 100%. So we're gonna just try to touch this up a tiny bit. doesn't like me. You need a little bit more of this. Here, come on, be nice and connect. On. Nice little blob. Okay. Okay, this doesn't look half bad. So basically there's nothing visually ultimately wrong with this. So I'm gonna take a short break, and after that we're gonna try and turn it on and see what happens. Maybe explodes into my face. So see you in a second. So I'm back, and in anticipation of what's gonna happen, I am gonna prepare a healthy beverage, an alcohol-free beer, and well, we're gonna give this a spin. So first I'm gonna pick my first OSSC or primary OSSC, and plug this in and turn it on, and you can see I don't have a very long cable, which makes this very hard. That it boots up. It shows on the screen and lights up, and it shows one LED blinking, but this of course is already a configured OSSC, so this is not what's going to happen with this one we have here. Now with this one, we're gonna expect plugging it in and crossing fingers, turning it on, and yeah, okay, so I don't know if you can see this very well, but first of all, the display lights up. This is a good indicator. This is okay, but it's blank because obviously the device doesn't know what it's supposed to do. Also, two LEDs light up here, and you'll notice both of them are red. One of them should be green, but I obviously soldered in the wrong color LED in here. But that's something I can live with for now. But important, both of them should light up. And if you get to this point, basically you're in rather good shape, which means there's no major problems with the soldering, and basically the machine is powered on and things are okay. Now, next thing we want to do is we want to check the ICs for heat, and yeah, that's basically one of the things. Of course, with me touching things here, it could be that I short something, so I have to be careful, but this just shouldn't get overly hot at any point, and is okay. So next thing I can do, I can turn this around and grab my trusty multimeter here. I don't know if you can see this, and while it's turned on, going to measure some core voltages. So I hope you can see this, and I'm again going to take my ground reference, which is my connector here, my VGA connector, and first thing I'm going to do is I'm going to check this, and this says 5.18 volts, which is 5 volts, which is fine. Now I have to be a little bit careful here now with touching these pins, and you can see that at the lower side of these two power regulators here, if I match it, I have 3.3 volts on U7, and I have 5.16 volts on, that's U6, which is exactly what I want to have. On the top left pins, I have nothing and 1.9 volts on U7, and I have near to nothing, and I have 3.3 volts on the lower left side. Again, okay. Then I have these U12 here, which goes to nothing and 1.2 volts, nothing and 2.5 volts, nothing and 1.2 volts, nothing and 1.8 volts, and nothing and 1.8 volts again. So the output voltages here are in the range of what I want: 3.3, 5 volts, 3.3 volts, 2.5 volts, 1.9 volts, 1.8 volts, and 1.2 volts. So basically everything here is okay so far. There's no weird wiring. Sometimes, for example, if you have this IC up here, so U10 soldered on the wrong way around, you're only going to get half the voltage of these 2.5 volts here. And here's the 1.2 volts again, and yeah, that's basically how all of this goes. Then we also have on the other side, we have our 5.1 volts here, not on the middle, and we have 3.3 volts on this side, which is exactly what we want here. So yeah, that's basically where we want to go and what we want to have, and this is looking good so far. And that doesn't necessarily mean anything, but you can of course check some more voltages on the capacitors, which should be 0 and 3.3 volts on this one, etc., etc. But usually, like, if you're in this state, you're good to go to the next step. Next step is going to be, we're going to check our JTAG connector, and we're going to have not 2.5 volts, 0 volts, 0 volts, 0 volts, 0, around 1 volt, 2.8, nothing, and 2.8 volts. So this basically says, okay, our JTAG connector has the voltages we would need to actually program the device. And that means I can now switch over to the Xilinx software, and we can have a look at how actually this is programmed. For that, I'm going to have to fiddle around with the stream a bit. So let's first turn this off, and I am going to need a USB blaster. In this case, it's this one, and I'm going to need an appropriate cable. And I'm going to choose this one. And I'm going to have to hook this up to my PC here. And now I'm going to have to configure this. And give you just a second to hook this up. Now, let's snap this on. So, okay, let's see if I can get this onto OBS. I'm going to add a new source, and it's going to be a composite window capture. And it's gonna be window capture X composite something something, and it's gonna be this, and I'm just gonna put this here and try to arrange this in a way so you can see this. And basically what I can do now is use my console to JTAG config, and this is going to show me that actually there is an EP3C16, EP4CE15 connected, which means the JTAG connection is successful, which means I can actually program the device. To do so, I am going to need another program, which is called Quartus, and I'm just gonna fire this up, and once it's fired up, I am going to add this as this window capture. So we're gonna size this down to where it needs to go. That's not the, well, it's not the best of the best, but in the end it should kind of work. And we're going to open the OSSC program, which is going to take a minute. And basically we're going to go and check the JTAG chain debugger and test the JTAG chain, and this is going to show, hey, we have a good JTAG connection. I don't even know if you can see this. You can't, so I'm going to add another window capture here, and I'm going to use this debugging window here. So basically what this is going to show you here is you push this test JTAG chain button, and it's going to show you that, okay, you have a device chain, which is this chip here, and it shows you a couple of JTAG connection is good, there's one device, here's blah blah blah, it has some weird user code stuff, blah. We're not really interested in all of this because we're going to close this back up. And after we've done that, we're going to remove one of these. Yes, I want to remove this. We're going to take this window here, and we're going to go into the programmer, and I'm going to have to change this to use the programmer. And this is what the programmer looks like. It has the auto detect feature, which detects this chip, and it actually loaded this SOF file, which means I can load it directly onto this onto this FPGA. This means that if I do this right now, the device is going to turn on with the firmware that's been already built. But that's not going to be persistent. If I remove the JTAG connector, it's just going to shut off. So I'm going to remove this file and add another file. And this is a JIC. And you're going to see a difference here now. If I set this to program and verify, now you're going to see that on the lower side here, it says, okay, put this into this controller and put that into this EPCS16, which basically is the factory default memory. So with this, we can actually start to flash the firmware permanently into this device, which is gonna always load this firmware from this chip on power up, which means if I push start now, it's gonna start progressing, and you're gonna see the USB blaster light turning up, and it's gonna verify, and it's gonna tell me, hey, 100% success. And you can see that the lights and the display have turned off. Basically, this means, okay, we're done here, and this is now basically caught up in a loop. And with a little bit of luck, if we turn it back on, you can see that it's now, looks like there's a wonky connection there. Yep, there's a wonky connection on the power connector. So you can see there's only one red light here now, which should be a green light because I messed that up. But it actually says OSSC firmware 0.83a, blah, 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 marks all's good. And if I turn this off and remove the JTAG connector, I can turn it on and it still has that firmware loaded. I can even unplug it and it's going to keep that firmware for as long as it needs. Now, as you can see, there is some issue with it, and I'm not sure what it is. But yeah, basically that means we've successfully flashed the firmware onto the device and we're finished with the Quartus software, and we can now use this device and actually upgrade the firmware by use of the SD card if we ever want to. So I can get rid of the programmer for now, and I can close all of this. And for first part, I can call this success, I guess. There's some not solid connection, which is something we're gonna have to figure out, but it does look like it's capable of turning on. And the next step we want to do is turn it on and press one of these buttons. This button works, which puts, if we press the inside button, it says press 1, which means this is now in remote programming mode, so I can actually program a remote control, and I have a remote control, and I can now start pressing buttons, and it goes from press, and there's the multimeter that tells me to turn off. And now I can actually use this to program the commands of this remote I have here. This is an ancient remote, and I'm just gonna go through a couple of steps here for a second. Back, up, down, left, right. We're gonna need an info, LCD backlight, scanline mode, scanline type, intensity, multi-line mode, phase plus, phase minus, and a profile hotkey. So now I've basically programmed the device, and I can set it's hard, but the cable's very short, so it's hard to see. I can actually go through the menu, use different settings, set up stuff, save stuff, and yeah, that's basically the first step I have here now. Now I can turn this off again. The next thing we're going to do is actually plug in some input and output to this device, which is gonna take me a second. So I'm actually gonna take this, and I have to do this off of the camera, so I'm actually gonna plug in an HDMI, and I'm gonna plug in a start connector, which goes to my Super Nintendo. And then I'm going to turn on the Super Nintendo I have here. And let's see this here. Hell, that red light instead of the green light is really confusing me. And now I'm going to see if I can just add let's see how I can do this. I can plug this in to my Elgato, and I'm just gonna remove the scope camera for now and plug in my Elgato capture card. And gonna try to start this up, and I'm gonna switch over to my normal camera here. I'm gonna go here and let's see what happens. So I'm gonna have a menu. I'm gonna have output options. 222 pass through. So this is just going to take a little bit of configuring here. And let's see how this goes here. And if we can actually see something here. Nope, nope, nope. No. So it doesn't look like I can get this started up the way I want to. And I don't know why that is. So I'm gonna just try and use this one here instead. Let's see what happens now.